We'll proceed in innovative approach in calculus. Multivariable multivariable directional derivative along a vector. What are you talking about? We talked about it. Directional derivative, directional derivative along a vector. Okay, so if I have 3D, I have 3D. What is 3D? 3D is nothing but if I have independent component at x and y, what is 2D? What is two dimension? What is two dimension? Two dimensional means I have x and y. X is independent and y is dependent upon x based upon a function f. F braces x braces close fx function over x. It can be sin x, it can be log x, whatever it is. So if I have two variables x and y, it is called two dimensional, where one is independent and one is dependent upon other. So they are tied to each other through a function y equal to function over x fx. What is three dimension? X, Y, Z, where x is independent to y and y is independent to x, but z is dependent upon x and z is dependent upon y. Z is function over x and y, x comma y. Okay, what are you talking about? If this is x axis, then this is y axis. If this is x axis, then this is y axis. This is x-axis, y-axis is 90 degree to x-axis. This is xy plane. Now, this is z that is perpendicular to the xy plane. Now, if I take any point x comma y and pass it to a function, then it compute the x comma y and come up with a height, come up with the numeric value. Okay, if I say y equal to fx, that is fx is sin x, then if I keep changing x, if I keep changing, if I keep changing x, okay, then I get different y. If I keep changing x, then I keep getting different y. Okay, in that sense, now if I have z equal to fxy, then if I keep changing x and y, then I keep getting different z. So how to draw z? I mean, if someone is writing in mathematics that z equal to sin x into cos y, z equal to x plus y, then someone puts x, someone puts y, and if we add, it becomes z. That is over, right? Okay, but it is very nice when we understand independent dependent through graphics. So if someone is saying z equal to x plus y, what about y? If y is dependent upon x? No. If I say, if what about if y is dependent upon x? Z is dependent upon x and y is dependent upon x. Then if I take any point, then it is x, y, z. Now that point can be said x comma fx comma gx comma y. X that is independent comma function over x that is y comma gx comma y that is another function g over x and y, or gx comma fx. This is the representation. But if x and y are independent to each other, then z equal to function over x and y. If we move ahead and draw in two dimension, if we move ahead and draw in two dimension, then this is x-axis, this is y-axis. This is xy plane. If this is xy plane, then vertical side, the side that is perpendicular to the xy plane, complete, that is it. I mean, if someone has better representation, then he can draw it. No one stops anyone doing the kind of invention what he is looking for. Okay, this is satisfiable to most of the people that we take x and y perpendicular to each other, and if this is line x axis and this is y axis, then if I draw a plane that is connecting both of them, this is xy plane. Whatever the height portion that is perpendicular to the xy plane is z. Now someone can draw it. Z equal to x plus y. Z equal to x plus y, where x and y are 0 comma 0, x and y are independent to each other. If x comma y are 0 comma 0, then their z is 0. But as we go along x-axis where y is 0, then z will be exactly equal to x. If I go along y-axis where x is 0, z is exactly equal to y. Otherwise, other places z equal to x plus y. Now, take all the points and draw the height point. Z is height. If x is 2 and y is 3, z is 5. So, if this is xy plane and this is the center, blue color, then if I take 2, 3. X is 2 and y is 3, this point. This point z will be 5 here. At the origin, z will be 0 here on the xy plane only. Okay, now on y-axis, that is 3, then z will be little bit high, x plus y. X plus y. On x-axis, x is 2, z will be little high, 2. Like that, z will be at height depending upon x plus y. Function over x and y is x plus y. Now, I have tons of points now. Based upon this formula, z equal to x plus y. What about z equal to x square plus y square? Can I take it? Certainly you can take it. Whatever is the need for you, you can take it. So in that way, connect, and whatever the, if you connect so many innumerous points, then it constitutes a surface, and that surface is three-dimensional surface. People also call 3D. 3D images, 3D images. 3D images is nothing but Z is dependent upon X and Y, where X and Y are independent to each other. Okay, what is x-axis? In algebra, uh, in algebra, what is z? Z equal to x plus y. In algebra, what is x-axis? Y equal to 0. That is the line. Y equal to 0 is also called x-axis. In vector form, it is called I vector or I unit vector, which has magnitude of 1. What is y-axis? X equal to 0. That is the line equation of y-axis. I cannot do anything. This is what it is. X equal to 0. X equal to 0. In that is equation of y-axis. Okay, if that is the case, then what is, consider I have taken z equal to x plus y. What is x plus y line? Okay, so x plus, if y equal to 0 is x-axis, if y equal to 0 is x-axis and x equal to 0 is y-axis, then what about x plus y, z equal to x plus y? What is line? Consider x plus y, z I take any value, 3. What is x plus y equal to 3? What is that line? X plus y equal to 3. Okay, if someone draw this line, this is x-axis, this is y-axis, then x plus y equal to 3 will be like this, where this is x-axis and this is y-axis. Then it will be like this. What it is actually, x plus y equal to 3. When x is 0, then interception on the y is 3. When y is 0, the interception on x-axis is 3. That line is x plus y equal to 3. Okay, consider I have a line that is x minus y equal to 0. Y minus x equal to 0. Same thing, right? Y minus x equal to 0 or y equal to x. That is the line that will pass the origin and it will be 45 degree from the x-axis. Anyway, now idea is, consider I have a 3D shape, and equation is z equal to x plus y. 3D shape, and that equation is z equal to x plus y. How much this shape changes on xz plane? I believe I am right. So this is x-axis, this is y-axis. Now this is xz plane, this is yz plane. In that case, if I have a 3D surface, then the surface is changing. If I take only xz plane, what is the change in xz plane? At what point are you looking for? Okay, at point x1 comma y1 comma f function over x1 comma y1 or z1, x1 comma y1. So if I take any point x1 comma y1, any point x1 comma y1, this point will hit the surface at some point, 3D surface. At that point, what that is z? Okay, so what is z equation? Z equal to x plus y. This is what we are taking. What is this? What is the variation of z that is seen at point x comma x1 comma y1 along x-axis? What are you talking about? What is the variation in z that is seen along y-axis at point x1 comma y1? I'm talking about dz by dx. Dz by dx, that is variation of z that is seen along x-axis. Dz by dy, variation in z that is seen along y-axis. Dz by dx, dz by dy. Repeatedly I am talking about it, right? So I have one kind of I really have a spare. Okay, so this is more or less a sphere, I believe. Okay, earlier it was like a paraboloid, but this is more or less it is a sphere. It is very round. It is very heavy though. Okay, now if this is a sphere, or if this is a sphere, then this is xy plane. This is xy plane. On top of it, this sphere sits. How I drew this sphere? This is not natural. I drew it. I drew it. What formula you use to draw it? Simple, right? At x comma y, any x comma y, use a function and get the z. At any x comma y, use a function, draw a z. If you connect all the z, it becomes like this. What formula you used? I used formula z equal to square root of a square minus x square minus y square, where a is some constant. Then it will draw a sphere with radius a. Okay, centered at the origin. If you don't want to be centered at the origin, it will have some lifting, right? It is not centered at the origin. This is xy plane here. If someone wants lifting, then z minus z0, that it will shift. From the origin, it will shift in z direction. Z minus z0 equal to square root of a square minus x square minus y square. What about I want to shift little bit along x-axis also? Z minus z0 equal to square root of a square minus x0, that much is the shift, square minus y square. I have shifted it to x0 y0 z0. More or less I am saying it is passing, the origin of this is passing, is is kind of x0 y0 z0. That means I shift. Earlier the origin is 0. Now origin is x0 y0 z0. Z minus z0 equal to square root of a square minus x0 whole square minus y0 whole square. Are you trying to say x minus x0 whole square plus y minus y0 whole square plus z minus z0 whole square equal to a square? This is what I'm trying to say. Where the origin x0, y0, z0. If that is 0, 0, 0, it becomes x square plus y square plus z square equal to a square. Z equal to square root of a square minus x square minus y square. where it is centered at the origin. If it is not centered at the origin, please settle it. Anyway, now if that is the scenario, I draw it. What is your question? Now my question is that if what is this point? Any point. If I take any point, what is this point? If I take any point here, that point is x comma y comma function over x comma y, that is z, x comma y comma z. Okay, if the point here that is drawn on, if the point, I'm talking about this point, if that point is x1 comma y1 comma fx1 comma y1, if x1 comma y1 is the point over which this is drawn, what is dz by dx? What is change in z I see along x-axis at point x equal to x1? What is change in z I see along y-axis at point y equal to y1? Makes sense, right? Okay, so I'm trying to find at any point, it's very heavy. Okay, it is very heavy. Okay, at any point, what is dz by dx? So if I cut it, in xz plane, it will form a circle. Okay, then dz by dx on that circle, this is the tangent we are saying dz by dx. dz by dy is, this is the tangent, that is dz by dy. dz by dx, dz by dx, what is dz by dx? Along x-axis, I am seeing how much z is varying. So this may result into one algebraic equation. If it results into an algebraic equation, keep changing x, and that moment keep changing the value of x, put a numeric value of x, and at that moment you are getting what is dz by dy. What are you talking about? Z equal to square root of a square minus x square minus y square. dz by dx equal to minus xy square root of a square minus x square minus y square. Now take any y, take any fixed y equal to 2, that is fixed. Okay, now keep changing x. If x is 1, then at point 1 comma 2, at point 1 comma 2, if I see how much z would vary, if I slightly change the x, dz by dx. Now take the x equal to 10. At point 10 comma 2, how much z is varying? If I shift 1 unit along x-axis, take x equal to 20 minus 20 by a square, that is the radius, that is also a fixed value. Square root of a square minus 10 square minus 2 square. Y I have taken 2. So at 10 comma 2, how much z is, how much variation in height I see when I move 1 unit, dz by dx. So minus 10 by a square minus 10 square minus 2 square, whatever it comes. Okay, if dz by dx, if x is positive, then dz by dx is negative. Can you see? If x is negative, then dz by dx is positive. Can you see? dz by dx, how much the height is gaining. If this is x-axis, there is point x1. At that time, in xz plane, there is a height called z. If I move 1 unit, then how much z went up? That is dz by dx. Okay, if it is negative or positive x, if it is centered at the origin, then I am talking about right side. Can you see right side? The z, if I move along x-axis, z is decreasing. Can you see? This is the slope. Slope is nothing but dz by dx. That is also called gradient slope. Slope of the line that will be found by z equal to dz by dx into x. That is a line that we call tangential line also. So it is decreasing. That's why dz by dx is negative when x is positive. But on the left side, okay, if you see, this is positive slope is there, but if I cross the origin, the slope is negative. So on the negative x, the slope is positive, and positive x slope is negative. dz by dx, what are you talking dz by dx? Oh, dz, change in z along x-axis. I don't know what is x-axis. We talk in algebra. dz by change in z, dz by y equal to 0 line. y equal to 0 line. Okay, x-axis. So change in z along y equal to 0 line. Change in z along x equal to 0 line. dz by dy. Change in z along x-axis, that is dz by change in z along y equal to 0 line. Got it, right? dz by dy is minus y by square root of a square minus y square minus x square. dz by dx is minus x by square root of a square minus x square minus y square. Got it? That is nothing but dz by y equal to 0 line, dz by x equal to 0 line. Got it, right? What about dz by another line, that is x minus y equal to 0? This is directional derivative along a vector. Right now I am saying directional derivative along any line. If I am saying dz by dx, knowingly, unknowingly I am saying dz by y equal to 0 line. dz by dy is dz by x equal to 0 line. Directional derivative along x-axis, dz by y equal to 0 line. Directional derivative along y-axis, dz by x equal to 0 line. Directional derivative along any axis. Axis is nothing but line only. What is the equation of the line? X minus y equal to 0. That is a line that forms 45 degree from x-axis passing through the origin. X minus y equal to 0. dz by x minus y equal to 0. This is directional derivative along any axis. Can someone calculate it? dz by x minus y equal to 0. dz by anything, any line. dz by y equal to 0. I know, no. dz by dx. dz by x equal to 0. I know, no. dz by dy. dz by x minus y equal to 0. I don't know. I don't know. I really don't know. Nothing. It's very simple, right? Z equal to square root of a square minus x square minus y square. D of a square root of a square minus x square minus y square by along the line x minus y equal to 0. Okay, I know along the line, but it will be what? dx square by what it is. This is directional derivative along any axis. Okay, to solve this problem, there is one Mr. Vector that comes into the picture. Now, vector is saying dz by dx. You are not saying I am trying to get the directional derivative along y equal to 0. Actually, you are trying to say dz by di, I vector. This is what you are saying. See how people are coming one by one. So dz by dx, when algebra comes, he is saying no. dz by dx is wrong term. dz by dy equal to 0. This is what you are trying. When someone is saying, if you are very much intelligent, now say what is dz by d x minus y equal to 0. 0. This is our way of proving directional derivative. Please do support us. +91 is the India country code. 94831 60610 is the telephone number. 94831 60610 is the telephone number. +91 is the India country code. Now, if this is the scenario, now person is sweating. Okay, so algebra person is sweating. Now vector is coming. dz by dx. No, not dz by dx. dz by di vector. I unit vector. dz by dy. No. dz by dj vector. Unit vector. Okay, if you are this much, now tell me what is dz by x minus y equal to 0. What is vector form of x minus y? Okay, the vector form of x minus y. Someone can deduce it. I'm not going anyway. It's pretty simple. Means if line is x minus y, how I can calculate a vector form of any line? Okay, what is the vector form of any line? This is what we are calculating. Okay, if that is true, then x minus y equal to 0. Okay, so what about vector? Can I take any point on the line? Can I take any point on the line? Then that point will be x comma y, xi plus yj. I'm right, right? xi plus yj. Okay, if that is true, xi plus yj, what is y? Y is x. Xi plus yj. What is y? That is x. X minus y equal to 0. If that is true, then that point position vector is xi plus xj. Okay, if that is true, then what is unit vector along that? Okay, xi plus xi plus xj. Okay, if I take out x that is common, then it is I plus j, more or less. So vector equation of x minus y equal to 0 is, because I took any point there x comma y connected to the origin. Okay, that is the vector, right? Position vector. That position vector is along the line only. Okay, this is x-axis, this is y-axis. This is any point x comma y. If I connect from origin, this is the line. This is what the line is, x minus y equal to 0. I took a point on that line only. If I connect from the origin, okay, if I connect from the origin, then that is the vector. Then xi plus yj is the position vector. Y equal to x, xi plus xj. If I take out x being common, I plus j more or less is the vector form. I believe it makes sense. Okay, someone can try x minus y, x minus or y equal to x is the equation. Y equal to x plus 3. That is the line that is shifted little bit up and intersecting y-axis at 3. Y equal to x plus 3. What is the vector form of y equal to x plus 3? If I take any point there, x comma y, then it is xi plus x plus 3j. Xi plus x plus 3j. Okay, doesn't look good, right? Okay, what about if I take any point, is it an assignment? If I take any point x comma y, any point x comma y, okay, if any point x comma y, then xi plus yj is the x plus yj, xi plus yj is the position vector. What is the vector that is perpendicular to this position vector? Okay, that is derivative of this vector. That is I plus dy by dx j. That is the vector that is gradient of this vector. In that case, it is I plus dy by dx is 1, y equal to x, 1. I plus j, I plus j. Okay, if I have a line, its gradient vector. Gradient vector is along the line only. So equation is I plus j. Okay. Similarly, if I'm going for a line y equal to x plus 3, again it is I plus j1. Anyway, someone can use parametric concept to place the offset out there. No one is stopping it. No one is stopping anyone. Okay, then it will be exactly like xi plus x plus 3j. This is actually the equation of that line. But in terms of actual vector, it will be I plus j. Parametric vector will be xi plus x plus 3j. Whatever form anyone try to take anyway. Now the idea is we are trying to calculate dz by x minus y equal to 0 line. Directional derivative of z along a line x minus y equal to 0. The vector form of x minus y equal to 0 is I plus j. So if I say dz by dx, we are trying to calculate dz by I vector, I unit vector. Dz by dy is, is dz by j vector, j unit vector. Dz by dx minus y equal to 0 line is dz by I plus j. But unit vector I have to take. So I plus j, unit vector is I plus j divided by a square root of 2. Dz by I plus j by square root of 2. This is the directional derivative of z along a line x minus y equal to 0. Understandable, right? Directional derivative of z along x-axis is dz by di, along y-axis is dz by dj, j vector. Then along x plus j vector is dz by dx plus x I plus j divided by square root of 2. Okay, now we have to find it, right, at the end. Now, how vectors are formed? Now, question is arising how vectors are formed. If I say I plus j is the line, it is combination of I and j. If you see very minutely, I plus j is the equation of a vector, then it is I plus j. I itself is a vector and j itself is a vector. It is addition of both vectors. So if this is x-axis I vector and this is y-axis j vector, or this is I vector, this is j vector, then looks like there is a two vector. One vector was coming from negative x-axis toward the origin and one vector was coming from negative y-axis toward the origin. So this vector is j vector, this vector is I vector. At the origin, they collided, or they become one energy. One energy is coming from here, one energy is coming from here. At the origin, both energy they combined and they moved in another direction. That direction is I plus j. So in vector form, if I say I plus j, then it is combination of two energy. One energy is in I direction, one energy is in j direction. If I say 3I plus j, then one energy is 3I in along I direction, strength is 3. One energy in j direction, strength is 1. That is 3I plus j. Okay, so this vector has a strength of a square root of 3 plus a square, square of 3 plus a square of 1 square root. Square root. Square root of 10 is the strength of this vector 3I plus j. Where individual strength of the vector they one vector is 3I, one vector is j. They got combined and become a new vector 3I plus j, which has a strength as a square root of 10 and direction is 3I plus j divided by a square root of 10. That is pure direction. Unit vector is pure direction. So vector is energy which has a strength and direction. So I plus j vector has a direction is I plus j square by square root of 2, unit vector, and it has power of a square root of 2. Okay, now we are trying to find directional derivative. This is our proof. Please do support us. So consider this is a circle. If I take cross section, if I take cross section of the sphere, it becomes a circle only, right? Okay, that we will see. I believe it will become too long. I can do in other systems. Anyway, now I am trying to find directional derivative of z equal to x plus y. Z equal to x plus y along a direction line that is x minus y equal to 0. Dz by dx, if I say that it is 1. Dz by dx, directional derivative along x axis, that is x plus y, is I. Dz by dy is j, because x plus y, if I derive, then it is I. X plus y, dz by dy, again it is j. Dz by I plus j by square root of 2. This is what we are trying, where z equal to x plus y. Okay, now how we can do it? Z equal to x plus y. If we see little minutely, consider, okay, consider this is a parabola. Consider this parabola. This is a sphere and parabola both. It looks like in between, right? Consider this is a parabola. Equation of what is equation of parabola? Z equal to x square plus y square. If that is the case, if I take any fixed value z equal to 1, then equation is x square plus y square equal to 1. No, no, this is the equation of a circle. Z, if I take fixed value of z, then 1 equal to square x square plus y square. If I take fixed value of z is 4, then 4 equal to x square plus y square. What we are doing? If this is the parabola sitting on origin, this is the parabola that sits on origin. At any point height 1, I make a cross section. At any point height 4, I make a cross section. If I look from the top, it is a circle. And if on xy plane, if I draw, then x square plus y square is a circle of radius 1. If I see x square plus y square equal to 4, that is a circle of radius 2. Okay, what we are trying to get at? If I say dz by dx, if I see the circle of radius 1, I believe I can proceed next session. Okay, now this is the xy plane. Now this is the circle of radius 1. Okay, I believe I can take it. Now this is the circle. This is the circle of radius 1 on the xy plane. Now I am growing the radius and it is becoming another circle of radius 2. Can you see this circle is growing on the xy plane? Circle is growing like this. This growth, whatever we are seeing the growth, that is the variation in z we are seeing. Z equal to x square plus y square. This change in z by dx, that is the partial derivative, right? Change in the z along x-axis, whatever the change, if this is x-axis, this is y-axis, this is first circle of radius 1. This is second circle of radius 2. Can you see this? If this is x-axis, then if I sit on x-axis and see up, then I'm seeing this is x-axis, this is z-axis. XZ plane we are talking. If this is x-axis, this is z-axis. If I see like this, then z is growing. Or if I have said this is x-axis, this is y-axis. On xy axis, in xy plane, I'm drawing a contour that is x square plus y square equal to 1 at height 1, at height 4. Then in that, I'm seeing something is growing. Right? If this is x-axis, this is y-axis. Now, if I go from radius 1 to 2, the circle is becoming bigger like this. That is the z that is varying on the xy plane. Dz by dx, how much that variation in the radius I am seeing, that is along x-axis. How much that variation I am seeing in the radius, that is from y-axis, x-axis, y. If someone is sitting on y-axis, then how much he is seeing the growth. If someone is sitting on x-axis, then how much he is seeing the growth? Dz by dx, dz by d. If someone is sitting on the line x minus y equal to 0, then how much he is seeing the growth? This is directional derivative. This is our proof. So, if I am saying that if growth is someone is seeing x square plus y square equal to 1, and this is x-axis, then it is growing, then how much growth we are seeing with respect to x-axis. Now, if this axis is turned like this, x minus y equal to 0, same is there. How much is the growth someone is seeing from the line x minus y equal to 0? From x-axis, he is seeing the top. From x minus y equal to 0, he is seeing here. His eye is here because that is the perpendicular. His eye is here. X-axis, his eye is here when he is seeing the change. Along y-axis, then his eye is here. When I is along x minus y equal to 0, when I is here, how this point is seen changing? If x is like this, then how much this point is changing along y direction? If y is there, then how much this point is changing along x direction? This is dz by dx, dz by dy, or dz by x minus y equal to 0. Okay, then how someone can say, then if I see vector notation, vector notation is nothing but addition of x-axis and y-axis. There is a vector called I vector and there is a vector called j vector. If I combine those, it becomes I plus j, or something like I vector separately and j vector separately, combination of both. If I am saying about dz by dx, that is the partial derivative along x-axis. Dz by dy, that is partial derivative along y-axis. If I add that, it becomes a gradient vector. Dz by dx, I vector, plus dz by dy, j vector. This is what it is. Now, if I am saying this unit vector, this line is I plus j divided by square root of 2. I plus j divided by a square root of 2. Now, if I say how much z is varying, how much contour is varying, then he is seeing here. If I turn this like this, then it exactly becomes how much he is seeing along x-axis. Okay, this is not same as earlier x-axis. Earlier x-axis was here, and he was seeing here. Now he is seeing here. Now, if I turn this, then whatever I was seeing, it came on top of it. That is how much is the directional derivative when I am turning this line along x-axis. How much is the directional derivative I am turning this line along y-axis. Can you see? He is seeing here. And along x-axis, what are you talking about? Then I am talking how I can achieve this. Now, problem is simple, right? If I am seeing the change in the contour along the line I plus j divided by square root of 2, can I see it if I rotate everything to x-axis? Now, the point I was seeing from here, that point came on the top. Okay, if I do like this, then what point was I seeing? It came in x-axis. That is exactly like dz by dy. Dz by dx, if I get dz by dx, whatever I get, that is along x-axis vector. Dz by dy, if I calculate, now this is any point x comma y. This is x plus y, xi plus j divided by square root of 2. This is a point, this is any point x comma y, any point x comma y. If I calculate dz by dx, then I get the directional derivative along x-axis. If I calculate dz by dy, I get directional derivative along y-axis. This much I know. Now, if I rotate this guy towards x-axis, then whatever I calculate, that is the ith component of the ith component, means how I can do it. That is the question. Then if I rotate like this, then whatever the derivative I calculate along the new rotated axis, that is the ith component of the gradient vector. If I rotate like this, okay, and then I calculate the derivative, that is the jth component of new vector. Okay, then how to do it? Then one way to doing it, what is this unit vectors? If now the question is arising, okay, I consider this as a point. All right, if this is the vector along which we are trying to calculate directional derivative. Okay, how I can change it to x-axis? It's there. I plus j divided by square root of 2, then it's x-axis. If I want to mold it along x-axis, that is the x-axis component out there. That is I divided by square root of 2. If I try to mold it along y-axis, then what is it would be? This vector would look how this vector would look. If I mold this vector along x-axis, then how this or I vector, how it would look? It would look like I by square root of 2, because that component is there, right? How it would look if I mold it along j-axis? Then it is j by square root of 2. Now calculate one derivative along molded like this, and calculate one derivative molded like this and add it. This is the fundamental of vector. If you have something in I direction, if you have something in z direction, just add it, you get along I plus j, I plus j. So what is along x-axis, that is dz by dz by dx along I by square root of 2, that is new x-axis. This is combination of I vector and j vector. What is if I mold it along x-axis, that is I by square root of 2. Now calculate the derivative along I by square root of 2, that is I vector, along the I vector. That is dz by that is dz by dx, dz by dz by I by square root of 2. Okay, means in that direction it is nothing but dz by I by square root of 2. Okay, so that is nothing but whatever we are differentiating along the differentiating along I by square root of 2, dz by dx into 1 by square root of 2 I. If I try to see from here dz by d any point, if I talk about any point x comma y along I by a square root of 2, that is dz by dx into 1 by a square root of 2 I. Now what about this direction, that is dz by dy into 1 by a square root of j. Now these two vectors, if I got, then to get the complete I just need to add it. So dz by dx into I by a square root of 2 plus dz by dy into j by a square root of 2 is the directional derivative along any vector I plus j. It is same as dz by dx I plus dz by dy j. Okay, dz by d I plus dot I by square root of 2 plus I by a square j by a square root of 2. I will rephrase it. So what we are saying, that how much derivative we are getting, along x-axis, how much derivative we are getting along x-axis dz by dx, how much derivative we are getting along x-axis, that is how much derivative we are getting along I vector dz by dx, how much derivative we are getting along I by a square root of 2 less I by a square root of 2 means I vector whose strength is 1 by a square root less dz by dx along I axis. The change in z along x axis is dz by dx. The change of z along I by a square root of 2 is less, that is dz by dx into 1 by a square root of 2 along I direction. Okay, plus dz by dy into 1 by a square root of 2, that is along y, it is less. Now if I add this component, I component and j component, that is the net strength along I plus j. So dz by dx into 1 by a square root of 2 plus dz by dy into 1 by a square root of 2. That is the net directional derivative along vector I plus j. It is same as dz by dxi plus dz by dyj dot product of 1 by a square root of 2I plus 1 by a square root of j. That is gradient of algebraic equation dot the unit vector of the vector along which we are trying to calculate the directional derivative. This is our proof, very scientific, in a sense that this is the actual using the strength of vector. Vector is nothing but combination of two vectors I and j. If I say I comma any point x, y, j, then vector is I plus j plus k. That is combination of three vectors, I vector, j vector, k vector. So if my line is I plus j, line can be anything, I plus 3j, I plus 5j, whatever it is. Whatever, if I take I plus 2j, this is the line. I plus j, this is the line. I plus 2j, this is the line. This line is how much along x-axis? That is I plus 2j divided by square root of 5. 5, that is the unit vector of this line. Then I by square root of 5, I by square root of 5 is the strength of this line if I mold it along x-axis. 2j by square root of 5 if I mold it along y-axis, that is the new vector, this vector's molded form along the x-axis, this vector molded form along the y-axis. Now if I mold it along x-axis, now calculate the derivative along it. If I mold it along y-axis, calculate the derivative along this, add it as per the vector. That will be along this direction. This direction, what is the strength? This direction, what is the strength? If you add in a vector form, this is along the I plus 2j. If that is the case, then dz by dx into I by square root of 5, because that is the strength of the new vector along x-axis. dz by dy into j by a square root of 2j by a square root of 5. Okay, now add it. So dz by dx into 1 by a square root of 2 plus dz by dy into 2 by, sorry, dz by dx into 1 by a square root of 5 plus dz by dy into 2 by square root of 5 is the net net derivative along line x minus along the vector I plus 2j divided by square root of 5. That is nothing but the gradient vector dz by dx I plus dz by dy j dot product of the unit vector of the vector. That is also not required. This is what is the concept of the new approach. Nothing is required. No dot product is required. That is simple dz by dx and whatever vector along which we are calculating, calculate the unit vector, because at the end we are doing the manipulation. Dz by dx is dz by I vector. I is unit vector. So dz by I plus 2j by divided by square root of 5. Actually, we are trying to get along a line. Line is changed into vector. And for vector, if you have x component, if you have y component, just add it. This is the vector technology. In that sense, dz by dx and whatever along vector you are trying to calculate dz by dx, that vector molded form along x-axis. That is nothing but first calculate the unit vector and then ith component. Okay, that is the ith component of the differentiation. Now that vector molded form along y-axis. Whatever unit vector had jth component, multiply with dz by dy, add it. That is the directional. Now someone can think that, okay, this is nothing but gradient vector dot product of unit vector of that vector. This way also someone can understand directional derivative along any axis, or he can compute all together. Okay, mind blowing, I am badly sweating. So this is the actual way of calculating vector terminology, primitive way. So primitive calculus where we do everything through algebra, not delta x and delta y. Primitive primitive vector, everything we do from addition of orthogonal vectors, not the delta I vector change or something like that. So what we prove we make in last video is a new way, fx plus delta comma y plus delta minus fxy by delta u, if you remember. But here we are using primitive vector form. Whatever you are trying, first try to get in the orthogonal component and add it. Right? If I have I vector and j vector, new vector is I plus j because I added it. Similarly, if I am trying to get directional derivative along any vector, get the x component, I component, get the y component and add it. So later someone can say dz by dx into ith component of the vector plus dz by dy jth component of that vector. It looks like the gradient vector of the algebra, that is dz by dx I plus dz by dy j dot product with the unit vector of that vector. So if vector is xi plus yj, then dot of xi plus yj divided by square root of x square plus y square. Amazing, mind blowing, right? So this is primitive vector. Primitive vector we calculate in this way only. That is the basic vector fundamental. Okay, not the new way. The previous video was new way where we think about delta exchange and those kind of things. Primitive way of vector, primitive way of algebra. Okay, please do support us and we'll try to do some example on it. Then we will move to move to partial Jacobian. There we have done some research out there also. Okay, please do support us.